This meeting is being recorded.
Problem 17 from chapter 21 asks us to draw the condensation product obtained when each of these following aldehydes are heated in the presence of aqueous sodium hydroxide. So our key here as to what reaction will occur, which will determine to be this aldol condensation above here, is that we are heating in the presence of aqueous sodium hydroxide. So when we think of the reagents, we should think of this over here, sodium hydroxide, comma, water, and then heat applied as well. So as I mentioned, whenever you have at least two equivalents of an aldehyde or a ketone, so we're only given one reactant here in parts A, B, and C, it's safe to assume that we're going to have this aldol condensation occur because of the reagents. Again, sodium hydroxide, water with heat, and we're going to generate with a combination of these two aldehydes or ketones, an alpha beta unsaturated either aldehyde or ketone, respectively. So since these are all aldehydes in parts A, B, and C here, we expect to generate the former, the alpha beta unsaturated aldehyde. So let's take a look here and see if we can predict with a little more detail our products here. So let's look at part A here. And what I've done is I've oriented the first aldol with the proximity of its carbonyl oxygen to the hydrogens of the other equivalent of the aldol. So I can circle both of those there. What happens is one takes on the enolate form here, or enol form rather, and that becomes nucleophilic. And then that will attack and form a bond with the electrophilic carbon over there. So we can see that a bond forms between that carbon and this carbon here. And I've tried to orient the molecule so we can see that where this carbonyl is, we're going to insert this carbon-carbon double bond, and we don't lose any carbons in this reaction. We can count here 1, 2, 3, 4, 5, and then we see that here 1, 2, 3, 4, 5, and then with this other aldehyde, we have the carbonyl, carbon plus 1, 2, 3, 4, 5. Again, these are two equivalents of the same starting material shown in A. So let's count here 1, 2, 3, 4, 5. All right, so this will be our product shown down here for the condensation, specifically the aldol condensation reaction of this aldehyde here. So let's take a look at B. We'll move a little bit faster now that we know what to expect. So again, the same reagents, aqueous sodium hydroxide and heat. We orient our two equivalents of our aldehyde so that we don't really have to focus on the mechanism. We can just do this condensation by removing water here. And then we're going to combine these two equivalents of this aldehyde. So once again, we're going to install a carbon-carbon double bond here. That's shown here. Then we can see the carbonyl oriented here in this fashion. That tert-butyl group would be with this equivalent here down to the right, and then you can kind of see this whole aldehyde has been added here. So once again, we didn't lose any carbons in our aldol condensation. We can shortcut this by orienting two equivalents of our aldehyde in a manner that we can remove the carbonyl carbon, the carbonyl oxygen, and then replace that site with a carbon-carbon double bond, and also remove from the enol those two hydrogens. So let's see once again in part C here, if we take two equivalents of this aldehyde shown up here with the cyclopentane ring, we're going to orient them once again in this fashion. So we have those two hydrogens, and that on the enol form here, and then the oxygen of the carbonyl of the electrophilic carbon here. orient in this manner. So we do our dehydration, and then no, we should have our product drawn here somewhere. Uh, well, it looks like our product disappeared, so I will try to draw it here quickly. We're going to connect those two structures by forming a carbon-carbon double bond here. So everything else will remain the same. We're just going to bond these two structures together in that fashion. So we really shortcutted part C there.